Good morning. So we're here to talk about personalized healthcare. Healthcare has long been considered one of the areas where AI could have the most impact, and progress is being made every day. Just yesterday, there was an article in Nature magazine about a chatbot based on large language models developed by Google. And in test, it proved to be more accurate than board-certified physicians in diagnosing respiratory and cardiovascular conditions, among other things. Now, you might say, yes, but you need, the personal touch of a doctor. Well, in the same line of tests, chatbots with a similar amount of information that were given to medical doctors scored higher on empathy than the human doctors. So there's been a lot of progress, and this is likely to, or expected to, lead to the democratization of healthcare, but also more personalization of healthcare. So we're going to hear more about that from our two panelists, and I'd like to start with you, Dagmar. You're a professor of artificial intelligence, and you are the founder and CEO of a company called audEERING, which uses deep learning to detect emotion and health issues from voice. So tell us a little bit more about what you do.
So thank you very much. I'm very happy to be here today, and also thank you for this very nice question. You just said before that the chatbot was a little bit more precise than some of our human colleagues. So actually this is not a large surprise if you're in the field for quite some time, because AI, or applied AI in that scene, allows for a large potential. So what my company, for example, does is we are emphasizing or focusing on voice biomarkers. That means we're detecting states and traits out of the biological speech production system, and also apply psychologically validated methods on the way how you speak. So we are not analyzing predominantly what you say, but especially how you say it. And that's a very interdisciplinary field where we have been scientifically researching for a good 20 years now. And
what can you detect from people's voice?
Well, basically, we can detect different type of markers in the area of, for example, neurodegenerative diseases, neurocognitive diseases, but also mental disorder that basically stem from the different type of influences in your voice production system, mainly the muscles that are being used, like your tongue, your cheek muscles, your breast muscles, your lungs. And if there is any type of anatomy deficiencies or any type of difficulties, you can see that in the audio signal. Similarly, if your brain, which is usually used to control this type of muscles, has some sort of deficiencies, like just think about fever, you're having a high fever, you're speaking completely differently, like much more monotonously, or you cannot control those muscle groups anymore, which is quite often the case in neurodegenerative diseases. You can hear this or see this already quite early on in the audio signal. Also, if you have physiological impacts like a tumor, head-neck tumor, or for example, if you have any type of mental stress, like cognitive load, you're speaking completely differently like you would do in a normal situation. All those type of little tiny impacts come together when we are calculating the probability of something being not normal in the case. We do not do any type of diagnosis and say, oh, you have cancer and you're going to die in 5 years. No. But what we do is we give a hint and much more precision to the possibility for screening, also for preventative measures, and once you've had your diagnosis, for enhanced precision medicine and individualized therapy, which is possible, of course, if you have different type of additional personalized input in that area.
Thank you. We're going to come back to your company in a minute and talk about how you are turning that into a business, your business model, who your customers are. But first, let me turn to you, Nikki. You have a background in both public and private health here in Europe. You worked at the European Commission for a while. Now you're the CEO of Epix AI. Tell us what Epix AI does.
So very much actually building on what Dagmar does and the way that they empower AI to use it for certain type of diagnostics, a very high level of diagnostics of certain conditions. In the same way, what we are doing is we're combining in one platform the power of AI with epigenetics so that we can measure accurately people's biological age, but also their predisposition and their risk of age-related diseases. Now, the reason why we're using AI is because if you're working with epigenetics alone, no one can really process that amount of data. We are collecting so much information on people's epigenetic profile. If we didn't have AI and machine learning, we wouldn't be able to process all of that data and to derive meaningful insights about people's epigenetic profile, their predisposition towards certain diseases, and the level of activation of the harmful genes that we all carry in our genomes, and what that means for the individual patient.
So, I mean, a number of people in this audience, I'm sure, use devices to track like how many steps a day they walk and so forth. But you have that information in a vacuum. You don't know for sure exactly how that's impacting your own health. So how does your company help put what you're doing in the day, what you eat, how you exercise, how do you translate that into how that impacts the way you age?
Right, thank you very much. So our platform, in addition to working with epigenetics and AI, we also take input from wearable devices. Many of you have the Aura, some of you have the Whoop, a lot of you have the Apple Watch. And in addition to that, not only do we take input from wearable devices, but also from geolocation. So geolocation gives us invaluable information on numerous factors such as air quality, solar radiation, meteorological conditions, elevation, all of these factors that impact our health on a daily basis. And a lot of platforms are neglecting them because they're not taking in that information. We are taking all of these factors and using our algorithms, which are trained on data sets of open databases about how these factors impact the human body and people's health. We are bringing all of this in our platform that gives you day-to-day advice on how your environment and your physical your physical activity, are impacting your health and how they're changing not only your biological age, but also your risk of age-related diseases.
Okay, thanks. So now let's delve into the businesses that you guys are building. So Dagmar, who is buying this technology and how are they using it?
Well, this technology is mostly bought by Fortune 100 companies, global Fortune 100 companies in the pharmaceutical sector. This is the one where we have two different types of products. One is more in the rather well-being area, where you're in the screening and prevention scene, and not yet in the pure medical scene. And this is a device-related product that you can put on your hearables, on your wearables, on any type of phone or laptop or whatever device you use to communicate with the client. And the other part is rather, that is interlinked with that product, by the way, a study platform that allows you not only to recognize voice biomarkers, but also to understand them and apply them. And this platform is rather used by pharmaceutical companies and by large research groups that want to do more or add on the voice as a part of a fully multi-sensor study. So our clients, for example, are in the automotive section. Our clients are, for example, companies like iMotion, where we are the exclusive partner for delivering the audio part that is used in very many research companies or research facilities. But our clients are also IoT companies, like, for example, Hanson Robotics is utilizing our technology for getting Sophia a little bit more empathic. We have other IoT companies that are utilizing this technology in their hearables, in their wearables, or on the phones or other IoT devices. And we base this, because you asked for the business model, it's a license-based business model where you basically purchase or pay based on the number of devices that utilizes that technology.
So your technology works on anything that has a microphone in it?
That's true. We only need a little microphone, and then we're happy.
Okay, and so we can expect to eventually, you know, and even now, find this in our earpods or in our cars.
Absolutely.
Okay. Let me pass to you now, Nikki. Tell me about how your business model works.
Right. So we have a two-level, sort of a two-revenue stream model, where the model for daily rate of biological aging rests on a subscription model. You don't need to take a test in order for us to calculate your rate of biological aging. We only need you to download our app and to give us access to your geolocation and to a wearable device that you have. And at that point, we can tell you, depending on, for example, if you've been in the park the past 24 hours, you've been breathing good air, you've been working out, and then you had a good night's sleep of 8 hours or more, we can tell you that for the past 24 hours, you've aged not 24 hours, but 20 or 19 hours. Conversely, when you've spent the whole day on the couch and you haven't been good to yourself, you've been watching Netflix a little bit too much, and you didn't have that much sleep, we will tell you that you didn't age 24 hours, you probably aged 29, 30 hours. So for that joy, we're going to charge you 13 euros. If you would like to have a very precise measurement of not only your biological age, but also your risk of age-related diseases, these are cancers, diabetes, dementia, all of these diseases that are triggered by our lifestyle, that is going to cost you a little bit more. We have a very broad B-sulfite sequencing testing, full B-sulfite sequencing testing, which is 1,500 euros. Once you've done that and you've determined what are your individual risks, you can take a more targeted test, which is narrower in its scope, but also costs only 500 euros. So those are our two revenue streams.
Okay, thank you. So, you know, so the measurement of our personal health and also our genes is something that is going to become more and more prevalent. In fact, it's expected that really almost everyone on the planet will eventually have their genes sequenced, but the analysis and interpretation of that information remains challenging because there's just so much data, and that's where generative AI comes in. And I think it's worth mentioning that one of our DLD friends, who I think is somewhere here in the audience, he's certainly here at the conference, is working on a stealth mode project. Sumit Jamer, he's a serial entrepreneur, and he and his brother are working on and a team are working on a project where they basically are using generative AI and large language models to annotate and interpret and prioritize sequencing to maximize the diagnostic of diseases. And their hope is that they will be able to use this technology in particular to diagnose very rare diseases that, you know, where the patients have had no hope before in the future. With that, I wanted to turn to our panelists to ask, where do you think AI is most effective today in healthcare, and where do we need to be a little bit more cautious about trusting in the in what AI tells us? Dagmar, I'll let you start.
Well, allow me please to answer the second question before the first one. So when we're talking about AI, there's a lot of myths sometimes out there, but in order to understand what's going on and also to be, that you can evaluate the decision that is being made, you have to at least look at three things that you have to know. What type of algorithm is it? How was it trained? And what was your database? That's the first three things that you just need to reflect when you evaluate some algorithm. And the other thing is also the benchmarking. There's usually things out there always like accuracy. Accuracy is the main thing. No, it's not. Sometimes 70% accuracy is a good thing. Sometimes 70% accuracy is not satisfying at all. It always has to be put into relation with your ground truth and what you're measuring against. So when we are talking about a risky thing where AI is not that good at all, we also have to always have to keep those two portions in mind. The algorithm, what type of training, the data, and the benchmarking, what is it evaluated against. And once we have that, we basically have a very good knowledge, or at least a sufficient knowledge, to answer the first question. And the first question, you can basically say, currently we have a lot of very good high-end performing algorithms. However, sometimes it's a question of transparency, and sometimes it's also a question of the decisive process. So how much, to what degree do you automatize in the process, and what is triggered next is the next question that you have to answer when you are going into the evaluation portion. For example, the vision part, like in radiology or in other fields, is quite mature in comparison to other ones. So here you have a very high density or very big progress and also comparison level in that field. When you, for example, punctuality go into rare diseases, you have not. This rare diseases part is a huge potential, and I love this project. It's really, really very cool because it provides you with a lot of exploratory possibilities here. But so there's more mature parts and less mature parts, although we have to say, or take it with a grain of salt, that the less mature parts are not necessarily more risky at that area. They just have to be exploited a little bit more, and we need more cases and we need more application in order to be able to evaluate what the potential really is.
Thank you, Dagmar, for putting that into context. Nikki, please tell us your point of view.
I think that we can all agree that AI is best suited in repetitive tasks with low risks.
Yep.
So if I have to break down the patient journey into 4 phases, starting with profile building and collecting information about the patient so that you can get an idea of their condition, their previous treatments, medications that they're on. Today already, people are often using Google as a source of information and as a source of self-diagnosis. And AI can very easily be applied in that scenario and in that phase of the patient journey so that doctors can quickly and accurately build an idea of what has this patient been through so far without actually risking a lot of the patient value, trust, which is very important. Moving on to diagnosis, I think we can both agree here we will need people's involvement for the future because this is a place where, depending on the bias in the models and depending on the databases that they've been trained on, there is still room for errors, and this is a crucial point in the patient journey where errors should be avoided as much as possible. Treatment is the next stage, and with treatment we are getting into the issue of liability. Ultimately, it is the healthcare provider that bears liability for the patient. And this is the stage where the contact with the human being is going to be the most intimate, especially if we're talking about tertiary treatments. I can easily foresee that this will be the stage where human involvement will persist for the longest period. And then ending up with follow-ups, where doctors frequently have issues staying in touch with the patient and making sure that they follow up with the right prescriptions and right medications, following up with the right exercises if those are necessary. Again, here I think that we can very easily anticipate a strong participation and a rise in the utility of AI. But beyond the individual patient journey, I think that we also need to consider the benefits for population health, statistics, and management. Because with AI, excuse me, we finally have the capacity, computational capacity to get a broader view of how a population is developing. What are the factors that are impeding a longer life duration? What are the factors that are inducing cancerous conditions, diseases? And can we eliminate them before they continue deteriorating the health of the public? So for me, that perspective, which is outside of the individual patient journey, is in fact very interesting. And I think that also companies such as ours and also Dagmar's really have a very interesting perspective and a very interesting position to influence policy making so that we can extend people's health span and make everyone healthier.
Fabulous. Thank you for adding your valuable perspective to this. And just as a last question, because we have to wrap up, we often focus on AI and health developments that are coming from the United States and Europe. You just came back yesterday from a tour of Oman, Saudi Arabia, and Israel with Germany's Federal Minister of Economy. Just give us a couple highlights of what you saw and why it's important that we are open to learning from others.
Well, I think it's a very difficult situation, for example, in Israel at the moment. But it's an extremely innovative area. And I think one thing that Europe always should do, Europe is really world-class in regulation, is to be more open, to learn, to observe. And for example, in Israel, there is that much innovation power, and also, for example, in the health area, so much gold standard validated data available in comparison to some areas here, that collaborations here would really, I think, speed up a lot of processes. Also, another thing is if we look, for example, into Saudi Arabia. Saudi Arabia has a strategy that, or a vision they call Saudi Arabia 2030, where the health and life sciences space is one of the biggest focus areas. They're completely redoing the health care system. They're completely redoing and digitizing the healthcare applications. And they're evolving AI with a much more positive spirit than we sometimes do. Sometimes we have a lot of fear and anxiety when it comes towards AI because there are so many myths out there. And once you demystify, everybody's like usually, oh, really? And I think this is one of those areas where we really shouldn't take the chances away by having a negative focus. Of course, we always need to have it in perspective. And regulation is not a bad thing, but it has to be done correctly. And observe what is going on in other parts of the world that really do this in a very disruptive way, and maybe take those portions into account when we're making certain decisions in order to make them a little bit more informed.
Thank you, Dagmar. I think this panel has really very well articulated the impact that AI can have on global health, particularly if we all work together and collaborate. And with that, I'd like to ask you to give a nice round of applause to